Welcome to this very last test review of the year, and where we're going to be doing graphs of conics. Now remember, within conics we have four different graphs. We have the circles, ellipse, and actually let me go ahead and loud for. We've got circles, ellipse, hyperbolas, parabolas, and really these they're related in some ways, and some other ways they're not. Now the first thing they want us to do is that they want you to identify it, and then after you identify, they want you to give in if you which one you pick out. They're going to want you to answer certain information. So like the first one that we have here, this is going to be, let's see, this is actually going to be a parabola. And the reason why we know it's a parabola, first of all, we have x squared, parabola. Hold on, got to switch the O and the A. Lovely. All right, so with this parabola, what they want us to do now is they want to know the direction. Well, here, let me highlight them for you. I want us to know the direction. Where is it? Direction, vertex, focus, and directrix. So first thing we got to do is look at the general form of this parabola. And one of the things you're going to be able to do is you're going to be given a sheet that will give you some information in regards to parabolas and what they should look like. But apart from that, there is going to be some part in your part, and where you have to realize that when you deal with these equations, actually I would say in this part you do need to memorize this. You do need to memorize that the general form of this equation, depending how it's seen, is going to be x squared is equal to 4a times y. Now I just want to go ahead and point some things out to you. When you have this kind of equation, first of all, when they're talking about direction, which is the first one we're talking about, this parabola is going to open up. So when we talk about direction, you have to talk about, is it opening up, is it opening to the side, and this one's going to open up. Now, how do you know if it's opening down? Down is going to happen if this is negative. It's not the case. This would be down. Okay, parabola opens down. Not the case in this case. How do you know if it opens to the side? Well, you're going to have the fact that you'll have y squared equal to 4ax. If you have this kind of form, you'll have one that opens over to the right, like in the positive side. So if you have this, so this one will open to the right. So you do need to know this. And if it's negative, that's going to open to the left. Left, negative. But we are not going to be covering that right now, because right now we're covering one that opens up. Now the important thing we got to keep in mind is that we have to know that the vertex in this case, the general form of this equation, also we have to know that it's like this. X minus h is equal to 4a y minus k. Since there's no x or h up there, it means something specific. That means that those values are 0. So for this one, our vertex will be at 0, 0. It's important to know. Now, what else as far as the focus? Now, the focus is found in this one particularly. If it opens up, focus is going to be somewhere at 0a. Because that means that we're going to have, well, let me draw my vertex. Here we go, vertex. It's going to be somewhere in the positive side. So we're going to expect for it to be somewhere over here, positive. But in our case, we need to find out what that is. Now, the nice thing about it is that it's pretty easy to find out what it is. And the reason being, you see how this 4a is going to be whatever this is, which means you pretty much set it equal to each other and find out what a is. If you're ever in doubt, just do that. Like if you're ever like, hey, what is that going to be? Well, just do 4a equal to 16, and then you'll identify what it is. Okay, great. So from here to solve for a, all we have to go ahead and do is divide by 4, and we'll get this lovely answer that says a is 4, which just means that this is really 0, 4. That's going to be my focus. So my focus will be this red point that's going to be 0, 4. Now, the reason why that is important is because my directrix, which is something else they want to know, is going to be directly located in the opposite direction, whatever it is. Like in this case, it's going to be y is equal to negative a, which specifically means that y is equal to negative 4. It's really easy to spot the directrix, and the reason being is because it's going to be equidistant from the focus. What do I mean equidistant? Same distance. 4 that way, 4 this way. That's what equidistance means. Let me go ahead and draw my line, which is the directrix. Now, the only thing you got to give importance is that if it's a horizontal line like this one, when it opens up, you have to put a y equals -4. The reason why I'm bringing that up is because if it opens over to the side, you have to be using x equals because it would be vertical lines as far as the directrix. Now, the only other thing that I need to do is come up with two other points. I think they identify that as locus rectum when it's off the focus. And really, the way we do that is go ahead and take your y value of the focus and put it into the original equation. It's all for x. So it's like this. X squared is equal to, go ahead and make some room here, 16 times 4, which is going to mean x squared is really equal to 64. Take the square root of both sides, you get that x is equal to plus or minus 8, which just means that given that you got the same point 4, you'll have it a point at 8,4 and at negative 8,4, which means that you have a point here, a point here, and now we can draw this lovely looking parabola like this. Fantastic. Let's go ahead and move on to the next. Now, with the next one right here, first of all, this one does look a little bit not confusing, but one of the things that we do have is we have 5 and 5, which are the same. So, first thing we should do is kind of, well, you could do this one or two ways. You could divide everything by 45 and then come up with these, come up with an ellipse, or you could divide everything by 5 and come up with a circle. And in this case, you get the same answer. Now, what I'm going to do is I'm going to go ahead and divide everything by 5 because it's easier to do this. And we're going to achieve this. X squared plus y squared is equal to 9. Now remember, with this one, this is clearly a circle. Actually, the other one, even if you divide it by 45 throughout, you'll still end up with the circle because technically, even though it's equal to 1, you'll have a squared and b squared equal to each other, so you get c squared equal to 0, which means you got a circle. Now, what's important to know about a circle is that the general form is going to be this. Now, the reason why this is important, first of all, with the circle and the instructions, I think they want us to come up with the circle. And let me erase some of these right here to make it easy to understand and highlight the ones that we need to come up with now. We now need to come up with the center and the radius. Now, the center in this case is going to be 0, 0, and the reason being is because there is no h and k. Typically, if you have this, then we'll have an h of k, but that's in your equation. But since it's not present, and guess what? My center is 0, 0. Now, it's lovely because it makes things easier on me. I would say actually with the circle, it's not that difficult, even if you do have an r and you're off center. But now we have to find out what this r is. R is going to be r squared is equal to 9. Take the square root, r is equal to plus or minus 3. So we have in this fact that we have an r, it's actually 3. What I mean by that is that we're going to, from the center, you got to draw 4 points. So the radius is actually 3. Now, why do we exclude the negative? Because it's a circle. So r is going to be a positive value. So this one's easy to draw because you draw your center, and then from there you draw 3 points. Everywhere from that center, you count 3 as such, and then try to draw a circle as best as you can. Lovely. So we're done with that one. Let's go ahead and move on to the next one. Let's see what the next one is. Okay, so this next one right here, it's a little hard to identify first without first. Well, it's actually kind of put it into order. This is a general form of the equation. It's not standard. Now, some of you are going to be tempted to try to put the x in the front because you're used to seeing that. Don't always do that. And the reason being is that do it only if the x is positive. Now, I want to point something out to you that's very important. Look at this. That's negative. If it's negative, it's actually going to follow this type of equation is actually going to follow a form which is known as a hyperbola. And the reason why I mention that is because a hyperbola has the fact that you got y minus k squared minus x minus h squared equal to 1. So you have this kind of format into it. And actually, I want to say that you also need to put down that in this kind of format, this is a squared b squared. So it's similar to the ellipse. So that's the only other one you could confuse one. But the defining point is this negative makes it into a hyperbola. If it was positive, we'll be dealing with an ellipse. But since it's negative, we're dealing with a hyperbola. So that's important to know. Now, what do we must do? To get it into this form that we just went ahead and wrote it here, we must complete the square on both sides. So let's go ahead and do that. Let's complete the square. Y squared minus 4y. Oh, hold on a second. Let me put some room here because I'm going to not run out of space, but I will run into the other equation I just wrote in there. I'm going to do this. Now, one thing to keep important, when you're completing the square, you want to get rid of a. So I'm going to factor that out right now at the moment. Now, I'm putting blanks here because we're going to have to complete the square. That's required. This comes out being negative 2x. And this is going to be equal to 4. Now, that's what's going to happen. When I come up with these numbers to complete the square, I have to also add it on the right-hand side of the equation. Keep everything even. Now, remember, completing the square, we have this magic number. We take b divided by 2 and squared. So like in this case, we're going to get negative 4, take 2 and squared. We'll get negative 2 squared, which means we get 4. We're going to put a 4 there and a 4 right over here. Let's do the same thing over here for this other one. I'll do the one on the right over here on top. And what I mean is that, let me go ahead and take negative 2 divided by 2 and square it. Negative 1 squared, 1. So this will be 1, but it's not really a 1 that goes in there. And the reason being is that if I distributed this out, I will actually have a negative 4. So negative 4 is really going to come over here. Now, why is this important? Well, it's important because we have to make sure that it comes out even. Like, one of the things that will be critical is that now these numbers cancel out. Now, what do we do after that? After completing the square, we're going to get into binomial forms. We're going to take the v value divided by 2. So like in this one, this is going to be y minus 2 squared. And on this side over here, this is going to be then, let's see, we're going to divide this by 2. So this is going to be negative 4 x minus 1 squared. And that's going to be equal to 4. Now it's at this stage that we go ahead and divide everything by 4. So divide here by 4, divide here by 4, and divide here by 4. And one of the things it's going to produce is now an equation that's going to have a format of this. It's going to have y minus 2 squared over 4 minus x minus 1 squared over 1 equal to 1. Now, this is important to know because one of the things that this points out, remember, this is a squared. So we know that a squared is equal to 4, which means that a is equal to plus or minus 2. And that b squared is equal to 1, which means b is equal to plus or minus 1. Now, the other thing we have to do with this one, let me just, the instructions call for in a hyperbola, center, vertices, foci, and asymptotes. So let's go ahead and come up with the vertices. Vertices, we kind of have them already. Now, with this one, we're going to have a hyperbola. Since y is the greatest, we're actually going to have a hyperbola that's going to open up and down. It's going to be parallel to the y-axis, which means that like the vertices, center, and the other vertices are going to be parallel to the y-axis. So we'll have virtually things that are moved off of the center. Well, let's go ahead and write down the center. And we'll start drawing some items that we actually know already. Now, the center in this one is going to be, remember, this is, let me write this down because I know some of y'all might confuse this. H and K. It's the value, it's the variable of the x that dictates that h and the variable of the y that dictates that k. So because of that, we're actually going to have 1 and 2. So that's lovely. Now let's move forward to now looking at the vertices. Now the vertices are just going to be an offshoot of the center. So if you had to write them down, you could do one or two ways. You could use a formula, or just go ahead and find the center, which is 1, 2. And then from there, know that you're going to go up 2 and down 2. So your vertices are actually going to be these values right here. Now you can also do it manually. There's nothing wrong with taking h of k and then adding those values k to it. Like one of the ones are going to be 1, 4. And so if you wanted to use the equation h k plus a, that's fine as well. But this is just a little bit easier because it's a little bit more visual. 1, 0. So we have these 2 vertices. They're going to ask you to list them. If they do in the such, you do need to find out what they are and actually state them on here. Now the other thing I need to find out is the asymptotes. Well, we have to figure out the asymptotes, but I want to go ahead and figure out the foci. Now the foci is going to be the c value. Now with these, we're going to be using the equation b squared is equal to c squared minus a squared. So we have b squared and a squared, and that's important to know because I can solve for c. 1 is going to be equal to c squared minus 4. So we're going to add 4, add 4. 5 is equal to c squared, which means we take the square root of 5. Square root of 5 means that c is actually equal to plus or minus the square root of 5. Now, in here, at this point, I would say it's a good idea to go ahead and bring out your calculator. And the reason why is that you want to find out, kind of get a number estimation of where the square root of 5 is. So you go ahead and graph it. Technically, what you're going to do is take your, if you're going to come up with the, like if they're asking for an exact answer, I'm going to go ahead and clear this. Second plus 1, 2. And let's go ahead and take to see what the square root of 5 is. It's going to be best for graphing, 2.23. So which means that, like in this case, when I write down my foci, it's going to also be affected by h, k plus or minus c for this one because of the locations. Which means that really I'm going to have 1, and wherever my center was, which was 2, plus square root of 5, and 1, 2 minus the square root of 5. Now, since we know that this is now square root of 5, since we know this is roughly 2.23, it gives me a good idea how to draw it on here, which is virtually right above my focus points. If I take 2 and add 2.23, I'll end up with 4.23, which is kind of there. And this other one will be right below there. And if you want to come up with, if you want to subtract 2 minus square root of 5, it will give you the exact side. Same thing with the other one right over there. Now, we have the foci. Last thing we need to come up with is the asymptotes. Now, I'm kind of running out of space here, so I'm going to erase some items and just take it from there. I'll hold on to some of the important stuff. Okay. Now, the asymptotes. Asymptotes in this case, when they open up or down, you're actually going to have the fact that asymptotes are going to be a over b. So the easiest thing to do is just find slope of them and just take it off your center, because if you use the equation, it will be difficult now. In a over b, my a value is 2, my b value is 1. So it's going to be my slope. So that means I'm going to draw 2 lines, plus or minus 2x as far as slope. So let's go ahead and draw that in. So that's these are my asymptotes. And if you write this for me, this is pretty good. Now, if you're technically going to do it exactly the way the equation is, then we actually need to write down y minus k, which k in our case was 2. And this is going to be 2x minus 1. And then you'll still end up with an equation that will virtually just produce this for you. We draw the slope from the center, just moves your equation around to account for your new center. That's really all it's doing. So we're going to have, there we go, asymptote like this, and then from this center, do the opposite, the negative 2x. Remember, I just drew y is equal to 2x off the center. I didn't use the equation, I just went it off the center. I did use the equation, but just not taking the center into account because it's doing the same thing as what I'm doing here. And if you do this for me, just tell me it's A over B and tell me your strategy. I definitely understand where you're coming from. So now, what do we do from here? Well, we're going to go ahead and now draw our parabola. I'll do it in black. So I want to go ahead and do it this way and this way. Lovely. There we go. Now there is some vertical, like a rectangular vertices that do apply to this. And the rectangular vertices are just going to be a format of h plus or minus b. So you know how we came up with the b value of 1? So my h value is here. Rectangular vertices are going to just be these. And the reason being is b is 1, which means that you're just going to go off this, go off either side as far as what we have for the rectangular. So if you want to write it down, rectangular h plus or minus b k. Now remember, this hyperbola was flipped on its sides. It's going to be plus or minus k. You know, k would be plus or minus b. So you just got to keep an account into all that. Lovely. Let's move on to the next one. And the next one, we're getting something that's slightly a little bit more difficult. Let's see what it looks like. Now let me erase. I'm erasing these items because I want to make sure I got enough space. Now let's, on this next one here, we're going to have, again, the general form of an equation. And in this one, we do need to put it in order. Now, if you notice, look at the x squared and the y squared, your highest degrees. So let me go ahead and point, get the highlighter out. Both positive, which means that this one's going to be an ellipse. Let me take that out. The only thing we got to do now is follow the strategy where we're going to have to convert this to standard form. So we're eventually going to look like this. X minus h squared over a squared plus y minus k squared over b squared is equal to 1. And first of all, we're going to put it in order. So I'm actually going to do it in such a way that I'm already accounting for completing the square. I'm going to leave some space there. Now, well, let's put it in order. We have to factor out both a's out of this one, but 25y squared plus 150y plus an unknown and negative 141. So let's go ahead and do this. Let's factor out a 4, x squared minus 4x plus 25 y squared, and that's going to go in there for 6 times. That'll be 6. 6y plus negative 141. Now let's go ahead and take our process of now completing the square. Negative 4 squared. I'm doing this first one, the x's first. Negative 2 squared. And then we'll get 4. So I'm going to add 4 here, but remember, since I need to distribute, that's really adding the 16. So this is really adding 16 here. That's important to know. That means 16. Now let's do the next one. The next one I'll do right up here to save some space. 6 divided by 2 squared. 3 squared. 9. So we're adding 9 in here. We're really doing 9 times 25. Now it should be 225. Because 4 times 25 is 200. But if you feel comfortable, always verify. Because in your case, especially in your case, I'm used to doing math a lot by my thought, but since you're not, you may want to just go ahead and just do what I just did to verify. So in this case, it'll be adding really 225. Now this one's going to be kind of interesting because now I'm going to erase this over here because I want to go ahead and have some space. Now I'm going to go ahead and now do binomial, convert these, make them into a single binomial. Let's see. We're going to divide this by 2. So we'll end up with x minus 2 squared plus 25. Divide this by 2. Y plus 3 squared. And let's do all this addition and subtraction. Negative 141 plus let's see, 16 plus 225, 100. So nicely comes out as a nice number, 100. Now we're going to go ahead and actually divide. Remember, we want that equal to 1, kind of like what we have in this top equation right here. So we're going to divide everything by 100 to achieve that. 100, 100, and 100. And we'll find out that this is going to look like this. X minus 2 squared over 25 plus y plus 3 squared over 4 equal to 1. So we have that a squared. Well, first of all, go ahead and draw our center. Our center for this. Now, actually, I'm not sure if that's the exact terminology from ellipse. Yes, they call this center. So we have to get the center, the vertices, co-vertices, and foci on this one. So let's go ahead and actually do all those steps. So the center we have, actually we have everything else as well. But let's go ahead and start with the center. The center is going to be the value. Remember, this is h, this is k. My center is going to be positive 2, negative 3. Always opposite of what you see. Now let's go ahead and find our, now with this one, you got to keep in mind that if a is the largest value, it's going to dictate which of these is a. This is the biggest denominator, so this is a squared, which means something important. If the a is in the x value, this is going to have your major axis on the basically on the, it's going to be horizontal. Major axis will be horizontal. And that's important because your foci is going to rely on that line. So right here, a squared is equal to 25, which means that a is equal to plus or minus 5. So my vertices, being that the major axis is going to be on the x-axis, it's actually going to be plus or minus 5 from the center. So which means it'll be, what I'm going to do is plus or minus 5 from here. I'll get 7, negative 3, and also negative 3, negative 3. And if you want to verify those points, just make sure you did it right. You could definitely draw the center. Let me go ahead and erase some of this to clear my graph. I have a nice looking graph, beautiful graph. 2, negative 3, so let's see, 2, negative 3, right here. And we're going to go 5 from this side, so if I add 5 here, I go 5 this way, I end up here, and actually I do end up with the points. They do confirm 7, negative 3, and negative 3, 3, my two vertices in this case. Now we have to go ahead and also define the co-vertices. Now the co-vertices are going to be off of the y. So like in this case, co-vertices are actually going to be, now if you want, I'll change color so you'll see. Actually, I haven't come up with the v value for the co-vertices. Let's go ahead and do that. B squared is equal to 4, which means that b is equal to plus or minus 4. Oops, plus or minus 2. Let's fix that. Let's see. Lovely. Plus or minus 2, which means that we're going to take plus or minus 2 from the y because we're going to keep that same x, and we're going to have 2. Let's see, we add 2 to that, that'll be negative 1. And if we subtract 2, we'll get negative 5. And again, you could go ahead and just verify that by taking plus or minus 2 from your center. So plus or minus 2 from my center, plus 2 here, minus 2 here. That's going to be 2, negative 1, and which is there, and 2, negative 5. So we have the correct values because they're also verifying the graph. Lastly, we're going to figure out the foci. Now the foci is done or figured out by taking your, now the equation on this one is slightly different. C squared is equal to a squared minus b squared. And with this one, we're going to go ahead and take c squared. We have a squared, which is 25, minus 4, which is b. Remember, you want to input b squared as you see to keep the minus. That's going to be very important because that's how this equation works. 21 We take the square root of 21. C is going to be plus or minus the square root of 21. Let's go ahead and kind of get a figure of what that is. But really what's going to do, remember, the center is going to be on the major axis, which is color. We're going to put plus or minus the square root of 21 from here. So if you're going to come up with exact points of what the foci is going to be a reference of 2 plus the square root of 21 to negative 3 and 2 minus the square root of 21, negative 3. This is exact, what I just wrote right now. This is very exact because square root of 21 is probably going to be a number with a lot of decimals. But we have to estimate where it's at. So let's find out what the square root of 21 is. Roughly 4.58. So that's important because I need to draw my foci. 4.58 from the center. So right here we go 1, 2, 3, 4. 4.58 right there. And 4.58 here. So we have that. And now you're able to draw your ellipse. Have all your points. Have everything that's required. And then we have our lovely answer. Okay, let's go ahead and move on to the next one. And now this one in itself, it's actually written slightly different. Actually, with this one here, you see how you have the y squared? It's the only one that shows up. If you only have one y squared, we're actually going to be dealing with the parabola. And since the y is squared, we're going to be dealing with the parabola that's either going to open to the side or to the, it's either probably going to be open to the side. Now, one of the things with this one is that, notice how we're going to complete the square on the left-hand side because we need to get, with these in particular, with the parabola that's not in the origin, we're going to actually have a form of this parabola. It's going to look y minus k squared and 4a minus x. So let me write that down. Write down what I'm saying verbally. We're going to have this y minus k squared, and we're also going to have 4a x minus h, like this. That's going to be our general form. So in order to get this left side to look like this, we need to complete the squared to make it look like that. So let's go ahead and do that. Let's do that for first part. Y squared minus 6y. Our numbers are going to be there. I have 12x plus 15 plus my number that's going to originate from completing that square there. So let's go ahead and do this. Find the magic number. Negative 6 squared divided by 2. Negative 3 squared. 9. 9. There's nothing on the outside, so that becomes 9 here. Let's divide by 2. Makes it one single binomial. Y minus 3 squared. And then on this side here, we'll have 12x plus 24. Now what we're going to do now is factor the right-hand side of this equation so I can find out what 4a is. So I could factor out, greatest common denominator is 12. I could factor out a 12, so I'll end up with x plus 12. I'm sorry, x plus 2. To get this. Now, 4a is equal to 12, which means that if you divide by 4, a is equal to 3. Which means that this equation can be written like this. Y minus 3 squared is equal to 4 times 3, x plus 2. And this is my a value here. That's important so I could go ahead and know where to draw the focus and where to draw the directrix in this case. Now, since this one's positive, that means if your a is positive, that means it's going to open over to the right. Because remember, this one, they want to know direction. So with this parabola, direction on this first. Opens to the right. That's the direction of it. Now, we are going to have a center. The center on this one is actually going to be, remember, this is h and this is k because of the y and x values where they're at. It'll be negative 2, positive 3. So we'll have negative 2, positive 3 right here. And then we're going to go ahead and have, from this point on, our a value, or because put the foci, focus, not foci, focus, because it's only one, it's going to be plus a to this one, so plus 3. So if you need to come up with the exact point, it's going to be 1, 3, and it's going to show up on here too, because we're going to, you count 3 values this way. So here it is. And to come up with the directrix, it's going to be the other distance. So we're going to do virtually our center, -2, and subtract a, which is 3, and keep the other 3. So we're going to actually get -5, 3, and this should be verifiable by doing the equidistance of this one right over here. And there it is. That's your directrix. The only thing is that, remember, directrix is not a point. This is just locational matter. It's going to be x. You could even take this off, that part of it. It's going to be x equal to -5. This is very important to keep in mind. Directrix is an actual line. So we have to put that down, otherwise we get the answer wrong. Now let's continue solving this and answering this by figuring out just how to draw this parabola off the center. And we're going to go ahead and use our original equation. Well, not original. The equation we came up with, this one. So now substitute the value of 1, where my focus is at, to figure out what y is. The other 2 points that go there. So we have y minus 3 squared, 12, 1 plus 2, which means we have y minus 3. This is going to be 3. 3 times 12 is 36 squared. Take the square root of both sides. Y minus 3 is going to be equal to 6 plus or minus, which means that we're going to have plus 3, plus 3. We're going to come up with 2 points. First one's going to be, now this is y values. 1, 9 would be one of them, and the other one would be 1, and now I'm going to do the -6 one, so -6 plus 3 is -3. So these points, we're going to have one at 1, 9, which is kind of right off the graph, and then 1 and 1, -3, there. And then you'll have a nice looking parabola like that. And so, lovely. Okay, let's go ahead and move on to the next one, which is 6. Now 6 is going to be an ellipse. Actually, you know what? The only thing we haven't done is that they want you to name these, so parabola. That's important because they want you to label each one. I want to make sure we label the other one as well. Hyperbola, that one. We didn't label the last one. So that would have been a minus point because it would have wanted to know that. So let's go ahead and write it in here, ellipse. This is an ellipse. The next one we're going to working on is going to be an ellipse. You might be wondering, how did I know that so quickly? Let me go ahead and tell you. And it had to do with looking at the highest powers. Look at the highest powers. Notice the highest powers. You see the highest powers, and the highest powers, if they're both positive, means that we're dealing with an ellipse. And they're both squared. And that's the case here. So all we're going to do is put them in order. X squared minus 4x. Let's see, plus. And I'm putting it in order so I could go ahead and actually do the completing the square of this one. Plus 6y. I'm leaving space because I'm going to have to add 2 numbers because we're going to make up 2 numbers here. So let's do the first one. Completing the square. -4 squared, -2 squared, 4. 4, 4. Right hand side. The y's. 6 divided by 2. Take the b value. 3 squared, 9. 9, 9. Now let's follow the process of dividing the middle number by 2. And let's form one binomial. There. So the same thing on the right side with the y. Divide the b value by 2. We get plus 3 squared. And 3 plus 4 plus 9 is 16. So we have this here. Now, this, I misspoke on this one. I said this was going to be an ellipse. Not the case. Not the case. Actually, I'm glad I didn't write ellipse. Why? I'm now identifying, remember, an ellipse or a circle is a special type of ellipse. It's so special, in fact, that we give it its own name. And one of the reasons why is that this is a circle is just because when you look at the format of it, it's following this format here. X minus h squared plus y minus k squared equal to r squared. So this is really a circle. So let's go ahead and actually state the correct thing that it is. Circle. The center of the circle is not going to be at the origin. It is going to be at 2, -3. The radius is going to be 4. R is going to be 4. You might be wondering why. Remember, r squared to 16. R squared equal to 16 means that r is equal to 4. So with this one, we're going to go ahead and draw 2, -3. And then from there go from 4. 4 in every direction. So actually this is one of the quicker ones we've been doing because it involves so much into everything else. Lovely. So we're done with this one. Let's go ahead and move on to the next one. Okay, now I want you to write the equation of the conic described using information provided. Then graph the equation by hand in the space provided, labeling all relevant information on the graph. So let's go ahead and do that. Now the first one, they're telling us what it is. We have an ellipse. So we have the foci, 3, -3. Okay, and that's important to know because that means that with foci, c is equal to 3. We have a vertex at 4, 0, and 0, 4. Now this tells you that the major axis is already on the x-axis, which means that the greater denominator is going to be at a squared with the x. Now this one tells you that a is equal to 4. What I don't know is what b is, but luckily, now, c squared is equal to 9, a squared is equal to 16. The reason being is that we have to figure out what the co-vertices are. And so c squared is equal to a squared minus b squared, which means we have 9 is equal to 16 minus b squared, which means we do -16, -16, we end up with -7 equal to -b squared. These multiply each side by -1, get a positive. And take the square root. B is actually equal to 7, square root of 7 plus or minus b squared, which is something we need to know as well, is equal just to 7. Now, why is this important? Well, if you need to know the general form of the equation in order to do this part, remember with an ellipse, this is going to be at x minus h squared plus y minus k squared is equal to 1, a squared, and b squared underneath. Now, my center is here, which is 0, 0, so which means I really don't need to use this form. Really, what do I need to use? This. Since the center, once you identify that the center is there, you really don't need to worry about it's really x squared, y squared. And then actually you could build your equation. Your equation is going to be x squared, 16, and y squared, 7, equal to 1. Now they want you to label everything. Now the only thing that I haven't done is draw my co-vertices. So let's do that. I want to get a good idea where the square root of 7 is. So let me go ahead and find out the decimal format. 2.64, which means that my co-vertices is going to be roughly here. 0.64, -2.64. Co-vertices, they want you to label everything, so follow the directions. Make sure you get all the points. Foci, vertice, vertice, and then just draw your ellipse. Ooh, hold on, I didn't like that. I started losing my path right after I hit that other vertice. Let's go back and fix that and make sure I hit that co-vertice, and there you go. There's my ellipse. Now we're going to be dealing with a parabola with a focus of 3, 5 and a directrix line of y equal to -7. So let's go ahead and do that. So 3, 5. 3, 5. Focus. And then y equal negative 7, y positive 7. So right here, y positive 7. Lovely. We need to, if that's the focus, and this is why, remember, they're equidistant. That means that my vertex, actually, no, is it no, it's not the vertex, it's the center. The center on this is actually going to be right there. That's actually where the, well, actually, you could talk about it as a vertex. No, the vertex is going to be right there. So my focus is right here. So it is a vertex in this case. Now, this is my vertex. The reason I knew that is that if my vertex is because, remember, it's the same distance, which means a couple of things. First of all, that means this is just the distance of 1 on either side. A is 1. The other thing is that now I can find out what value my vertex is, which is 3, 6. So my vertex is 3, 6. My general form of this equation is going to be this. X minus h squared is equal to negative 4a y minus k. The reason why I know is that it needs to be negative because it's opening down. So actually I have all the components now because I have a and x and everything else. So in this one, this parabola will be opening down. They only want the equation. Do they want to label all parts on the graph by hand, leaving all relevant information on the graph? Okay, so the only thing we haven't labeled is directrix. My equation is going to be this. X minus h, so x minus 3 squared minus 4 times 1, y minus 6. If you want to just have a real concise, neat graph, this is really negative 4, y minus 6 in this equation, standard form. So this is lovely. We have that answer. Let's move forward. All right, now we're going to draw an ellipse. Now the center of this ellipse is going to be, let's see, negative 1, 2. Focus, negative 1, 1. So here's center. Vertex, which means the major axis, and the vertex is a negative 1, 5. All right. This is the center, which means that we have another. Hold on. No, this was focus. Hold on. I miswrote that. Write this and redo this again. Focus. This is vertex. Now, this tells you a couple of important things with the graph. If this is the center, the other focus point is going to be here. So if you want, let me go ahead and color coordinate that to make it look nicer for you. I want to make sure you understand that these are focus here and here. So this is also a focus point, or one of the foci point, not focus, one of the foci point. We want to change this to plural because now we want to make sure you have 2. So this is foci and this is a foci. Now the other vertex is going to be at, now remember it's going to be equidistant, so this is 1, 2, 3, so you're going to count 3 this way. 2, 3. So here's my other vertex. Now a couple of important things I know. I know A and C already. From the center, C is going to be equal to 1, which means C squared is equal to 2. No, C squared is equal to 1 still. Oh, let's go ahead and fix that. C squared is equal to 1. Lovely. Now let's go ahead and now talk about to the vertex. From the center to one of the vertexes is the value of 3. So that means A is equal to 3. A squared is equal to 9. That's important to know. We need to come up with what B is. But we could do that because C squared is equal to A squared minus B squared. 1 is equal to 9 minus B squared. Minus 9 minus 9 cancels out. We get negative 8 is equal to negative B squared. Positive, positive. We multiply everything by negative 1. Square root, square root. Well, let's write this in. B squared is equal to 8. B is equal to plus or minus the square root of 8, which is, we also have to know the approximation of that. Let's bring that up. Square root of 8 comes out being 2.82, 2.83 roughly. So estimation 2.83, which means that when I build my equation, first of all, you have to know the standard form. Now, you're going to be given a sheet that's going to give you some of these equations as far as like, hey, this is an ellipse. And in one of them, you'll have, oh, hold on, that wasn't right. Y minus k squared. Remember, this is going to be, actually, no, in this one, it's going to be reverse. Because the major axis is on the y, which means with this one, we're going to draw just slightly different. Or label it slightly different because of the y being in the major axis. We're going to have y minus k squared. Okay, great. So we know that b is this. So now we're rewriting the equation because in this case we have a squared as being the largest, and then x minus h squared over b squared equaling to 1. So what we're going to have is this. We'll have y minus, my center was given at the value negative 1, 2, so that means it's going to be 2. Square my a squared was 9. X plus 1, because that's a negative 1. My b squared is 8. It's going to be equal to 1. My co-vertices, the only last ones I need to draw is 2.83, so, oh, actually, went a little too far. Well, hold on. 1, 2, no, actually, did not go far enough. 2.83 here, 2.83 here. Co-vertices, co-vertices. And then from there, let's draw my ellipse. So I have the ellipse that forms this way. Lovely. Actually, it's very circular because the A and B are very close to each other. Now let's go ahead and move on to the next one. Next one, they want us to draw a hyperbola. A hyperbola, we have the vertices negative 3, 3. So negative 3, 3. There's a vertice there. And 5, 3. 5, 3. Okay, so this one's going to open. It's going to be parallel to the x-axis in this case. We have a focus point at 7, 3. Okay, so what information I have given? Now, first of all, for the vertices, my center is going to be right here. Because remember, it has to be the same distance. This and this need to be the same distance, which puts it there. So first of all, I know that my A is going to be a value of 4. My center is going to be a value of 1, 3. My C value, taking off the center, means I'm going to have 6. 1, 2, 3, 4, 5, 6. So my C value is 6. And we have to know the square version of this. So A squared is equal to 16. C squared is equal to 36. This equation is slightly different, where B squared is equal to C squared minus A squared. So in this case, we're going to have, well, hold on, let me make sure I wrote that right. Let's see. Yeah. So C squared is going to be 36 minus 16, which means that B squared is actually equal to 20. Square root of 20 means that B is going to be roughly plus or minus the square root of 20. So now the important thing we want to keep in mind is B squared is equal to 20. And B is equal to the plus or minus the square root of 20. Now when you're going to come up with the equation on this one, we're going to have this. You know, that's really all they want is the equation. As far as filling out the graph, possibly could do it if they ask for it. Let's go back to the original equation. Write the equation, commonly describe information, then graph the equation by hand and space provided. All right, so we do need to graph it. So let's go ahead and graph this equation. Like in this case, we are going to have, let's see, okay, we're going to use this equation in this case. Now this one's going to be parallel to the x-axis, so it's going to be x minus h squared over a squared minus y minus k squared over b squared equal to 1. So we're going to have x minus, let's see, we're going to x minus 1 squared, and my a squared is going to be 16 minus y minus 3 squared. My b squared is equal to 20. That's going to be equal to 1. The last thing we have to find is just if it opens up to the side the way it does, that means that we're going to have b over a as far as the slope for the asymptotes. So like with this one, hold on a sec. Okay, great. And we have our equation. Now, if you're going to draw this out, you are going to have another vertex on this other side here. So we got 6 this way, 2, 3, 4, 5, 6, 6 this way. So we have a point there. And let's see. 1, 2, 3, 4, 5, 6. We got a point there. And then after that, we're going to have b. Now with this one, since it opens up to the sides, we're going to have b over a. So off the center, we're going to have these asymptotes, which are going to be roughly square root of 20 over 4, which we said the square root of 20 was, what value is that? I don't think we came up with that value. But let's find out what it is. Square root of 20 is 4.47. So basically 4.47, so it's virtually almost 1. It's going to be like 1.11. So we're going to have from here center, 1.11, 1.11. It's going to roughly go up a little bit. We have from here parabolas that kind of form this way. So we're going to have that. So there's our hyperbola. Now let's go ahead and move on to the next one. Now with this one, they want us to draw a center at 4, -2 transverse the x-axis. So this is going to be another hyperbola. So center at 4, -2, which is here. They give you A and C. So that means that from here you have reverse vertex this way, this line this way. And the only reason why transverse axis parallel, transverse the axis parallel to the y-axis. Oh, so this one's slightly different. We're going to be parallel to the y-axis. So when you're parallel to the y-axis, you're not going to have this here. I misinterpreted. I said x-axis, but no, they said parallel to the y-axis. What do they mean by parallel? That means the line gets formed, like wherever your vertex is at. Like these are, here's a vertex. Here's another vertex. Here's your center. And then here's 3 equal 4. 1, 1. That's the center, that's the center. So, and like in this case, we're going to have from here, we'll still have, so we have A and C, so A is equal to 1, so it means A squared is equal to 1. C is equal to 4, which means C squared is equal to 16. We have the equation C squared is equal to B squared minus, is that, no, it's the other way around. B squared is equal to C squared minus A squared for our hyperbola. So in this case, we have B squared is equal to 16 minus 1. B squared is equal to 15. The reason why this is important, once you have B squared, you could write your equation. The center is going to be, in this case, now the biggest one is going to be the y in this case. So if y is the biggest one, actually, the y is going to be the biggest one. We're going to have y minus k. Y minus k, so plus 2, because of this value, divided by a squared in this case, which will be 1 plus, actually not plus, minus, remember hyperbola, so this is squared. Oh, hold on. X minus 4 squared over b squared, which is 15, and that's going to be equal to 1. So that's going to be your equation. Now, you should go find the asymptotes and everything else. Actually, asymptotes should be pretty easy to find. This will be a over b, which would be 1 over whatever the square root of this is, 15. And then you'll be able to do that, and then you go ahead and draw this. Remember, these are focus, and you can label your asymptotes and do all that by hand. Now, moving a little bit more quickly just because I want to get through the important parts of this. So actually, well, let's see, I think we only have, I think that one's it. Ooh, lovely. So let's make sure. Now we have one more. So let's go ahead and actually fill this one out. What are the asymptotes going to look like? Remember, we want to figure out y is equal to b over a plus or minus x. So y is going to be equal to square root of 15 over 1. And we'll figure out what square root of 15 is in a second. Okay, great. Let's go ahead and now do this very last part, which is taking the square root of 15. And so we're going to know what the asymptotes are. So it's going to be roughly 3.8. So that means with this one, it's just going to go up kind of quickly. What I mean is that, and that's the reason why the focus is so high, because if you notice from here, 3.8 is going to be there, there. So we'll have an asymptote that forms this way, 3.8, there, and so on. And then this other one will be negative 3.8, so 3.8, so roughly there. And this way as well, so we'll have two parabolas that kind of go this way. We have our asymptotes. Y is equal to square root of 15 over 1, and y is equal to negative square root of 15 over 1. So we have all that said and done. Lovely. Now let's do the next one, vertices and an asymptote line. So that means that this one is probably going to be another hyperbola. So let's draw the vertices first of all. 4, 0. 4, negative 4. Okay, if this is the case, that means that this needs to be the center because of where it's at. And then we have the line y is equal to 2x. Now remember, we're going to have negative 2x plus 6 and also pi y equal to positive 2x. I'm not sure it would be plus 6, but really what the important thing we want to keep in mind, their slope is going to be negative 2. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So there's our first equation. And really what I did is I took the center and drew the slope. And we're going to have our next one. So here's the asymptote line. It's formed there. And the other one's going to do the same thing. Oh, I think I misdrew that. I'm sorry about that. Okay, so let's go fix that. Erase these other points here. So we have that there. Hold on. No, that's not centered. Looking at this, I'm like, you know what? Okay, so the first one was fine. I went to use the vertices to draw the center. From center, here you go. From center, so we'll have that there. And so your parabola will be built this way. So we're going to have, in this case, a vertice, while we're going to have a hyperbola, opens up and down. So we're going to have y minus, so first of all, a, because of the distance, a is equal to 2. Because here, 1, 1, 2. Now, apart from that, since we know a is equal to 2, so that means that a squared is equal to 4. We have, in this case, y is equal to a over b. It should be a over b, because it's opening up and down. So if that's the case, it means y is equal to 2 over b. And let's just pick a y point in this case. So we're going to pick let's go ahead and use the equation to figure out what one of the y's is going to be. Because that actually needs to give us our actual b value. So let's use the equation. Okay. Let's use the point -2. A is 2, so that's going to be negative, plus or minus. So we'll have that, so that's given plus 6. So let's pick a point. Why did we pick 0, 6? 6, 0, which means that 6 is equal to -2 over b. And really the point I picked out was this one, which is 0, 6, so 0 will go in here. Well, eliminate my b. Okay, pick a different point. Let's pick, because remember I want to solve for b. So that's not going to work. Let's pick something different. Let's go ahead and pick the point, this one right here. Let's pick 1, 4. Which means that this is going to be then, this is y. So let's, okay, good. So we're still in search of this b value. So let's go ahead and now fill in our point 1, 4. So it's going to be 4, this is going to be 4, this is going to be 1, and this is going to be 6. So let's go ahead and do some algebra here. -2b plus 6 minus 4 minus 6 minus 6 cancels out. We'll get -2 is equal to -2b. And then after that, I'm going to go ahead and just, you could flip both. This is, you really could do this. -1/2 is equal to b over -2. So then after that, we'll multiply by this -2, this by -2. This gets 2 over 2, which means that b is actually going to be equal to 1. So we found out that now b is equal to 1. B squared is equal to 1, which means in this case, in writing this equation, we're going to have, let me extend this page. Now, since this one's transversing the y-axis, it's parallel to the y-axis, we have this equation, y minus k squared over a squared minus x minus h squared over b squared. It's equal to 1. So let's go ahead and fill the stuff we know. We know that we have y, and our center was, what was our center? 1, 4. So, is it 1, 4? No, center was not 1, 4. Our center was here, which was the point 4, -2, which means that this is going to be +2 squared minus 8x minus 4 squared. And then we're going to have our a squared, which was 4. Our b squared, which we found was 1, and that's equal to 1. And we have our last equation here. Okay, lovely. All right. Hey, listen, I'm glad you watched the video. Now, this is a lot of information we took in. So what I need you to do, and this is important, is I need you to go ahead and go back and write these problems on a separate piece of paper without any kind of, well, let's let these bells go all the way through. What I want you to do is go back and write down all these problems, separate piece of paper, and then see if you could test yourself. You got to be able to do this by yourself without looking at this video or looking at your work. Do you remember, first of all? Second part, do you understand? And lastly, can you apply? These, as a minimum, are the 3 things you got to be able to do by yourself. Now, if you could go ahead and then show somebody what you're doing, then you're actually more in a sense than moving on to analyzing and evaluating. So if you could do that, that's even a plus. But remember, this is as a minimum in order for you to do well in the test. All right, good luck, everybody.